Here's a quick review of calculating the flow paths for a data set. Now, you should have done this in the course that's required, but in case you don't remember, we get to the hydrology tools and spatial analyst tools within ArcGIS. And if we look at the metadata for the LiDAR data on the MinTopo site, we can see in order to do our first step, our fill, we need some idea of how much we're going to fill. Now, we could use the sync function to give us a notion of what the sinks are, but we can also look at the metadata to guide us to get an idea of how deep we expect an error to be. And this shows basic errors about 10 to 20 centimeters, so we'll use 15 centimeters as a starting point. It means we're going to fill areas that are 15 centimeters deep or less. If it's deeper than that, we're not going to fill it. So in the fill, you identify the input raster and an output surface, and it creates a DEM filling any sinks that are 15 centimeters or less deep. So this process is first you fill the DEM, then you get the flow direction, then you get the flow accumulation, and then you can do snap pour points and do the watershed. So here we're just identifying the output raster, and I usually give it a name with a fill on the end. Once we enter the name, we have to add or specify the Z limit, the depth to which we're going to fill. Now, from our metadata, we want this to be 15 centimeters, but we have to use the units of the data set, and that's meters. So we enter it as 0.15 meters, and you let it run, and it runs reasonably quickly. If you look at the results, we can actually look at what's going on and see that it's running and make sure that it didn't crash. Now, the filled EM is added on completion, so now I'll calculate the flow direction, and that gives you the D8 flow direction. The 8 cardinal and subcardinal directions are represented by a number, and if we use our fill as an input, it tells us where each cell drains. Now again, I give an output name, this FD1, and I'm going to basically save it with my other data, and it calculates the flow direction. Again, this should be fairly quick, and it looks kind of goofy. It's just a step along the way. Now, we can go ahead and look at the sinks here in this flow direction. It'll tell us where the sinks are, and we can inspect them. So here we're now going to call it the sink data set, and so we'll go ahead and save that and run it, and it'll give us sink values for this. And here we have our sink data set. Now, from the flow direction, we can see these are the places where we might have low areas even after we've done the fill. So we could go and fill again, or we could look at them and say, well, are these likely sinks? And in this case, most of them are. They're basically low areas out in the fields where they don't need drainage and nothing drains, or they're a low area down in the parking lots at the low end where they've built berms and things. So some of these sinks we want to leave. Some of them are because they're under buildings. In this case, the DEM's kind of goofy around buildings because it has a hard time figuring out what's the ground under a building, so you get these weird shapes. And in some cases, you have drains in sink areas. So we're going to go ahead and live with these sinks for now. Or if we thought there were ones that were goofy, we could make another fill that got rid of those. But since we're going to accept these, we'll now go with the flow accumulation. And this uses the flow direction as the input and identifies then how many cells flow into each cell. So here I give the flow direction as my input, a flow accumulation, this FAC1 as my output, and I'll let it run. Now, all these are raster outputs. This is a float raster. Most of the others have been integers before then. And so I get this flow accumulation, which looks mostly dark because the smallest is 1 and the largest is the one that gets the most cells. So I can recolor these setting a threshold. Now I tell you to set the threshold for worrying about watersheds at around 5,000, but here we're going to do 1,000 and 2,000 and others, so you can sort of see as the flow accumulation increases. So we're doing 3 categories, 1, 2, and 4, and I'll give them colors. The 0 to 1,000, we have no color at all because we want to be able to see through it to what's behind it, and we'll give increasing levels of blue for the ones that accumulate more. There are very few once you get to these larger numbers. And now we can see we have the equivalent of streams. These are the surface flow paths. And so we're getting closer to something useful. We want to see where these surface flow paths run relative to our drain. So here we have the drainage. If we get surplus in an area above 1,000, 2,000, or 4,000 cells draining to these areas. So our next step would be to modify the pour points and calculate the watersheds.